think about this problem here. Show me with your thumb when I've given you enough time. Okay, somebody want to tell me an answer? Arzu, what'd you get?
46.
Okay, you might get a different answer. Mary, what'd you get?
44.
Madison?
36.
36. Okay. Is everybody happy with one of these three?
Yes.
Okay, all right, now we have something to defend, right? So when you tell me your strategy, I want you to tell me which answer you're going to defend. Okay, Saya, tell me what you're defending.
36.
36, okay. Go ahead and tell me what you did.
70 minus 30, I knew that was 40. So then I minus 4, that equaled 36.
I see.
Once
Okay.
again, I switched those two out.
You did, so you did 70 minus 4, and then you like taking the 30 off at the end. Okay. Mary, tell me what you're defending and what you did.
I think I'm going to defend 44,
Okay.
so I'll know what I did wrong.
Okay. All right, tell me what you did.
And now it's in my head. When I was doing the problem, mine was the same as science, but I thought when I got the 4, I thought I was supposed to add the 4 to the 40.
Does it make sense now why Syed subtracted that? The problem said to take 34 away. He took his 30 and his 4 away in two different parts. Okay. Okay. Andrew, what you do?
I added 6 to the 40. I mean 6 to the 34.
Okay.
And then
To get 40?
and then I added 30 more to the 40, which got me to 70.
Oh, okay. Let's see.
And then the 30 and the 6 make 36.
Okay, so that got you to 70, and so you just you basically counted up without a number line. So you knew, you went to a number that ended in a 0 by adding a 6, and then you knew that 30 more made 70, and 30 and 6 make 36. All right, I see. Did you follow Andrew? Okay, all right, Grant, do you have a different way? Okay. Which one are you defending first?
36.
Okay.
I took the 70 and I made it 76 minus 40. And 76 minus 40 is 36.
That was a more simple problem than this one, wasn't it? Can you explain why you or how you renamed it and knew that it would work?
I tried to find the nearest 10 for the 34, and that was 40. Well, yeah.
Okay.
And so then, I had to add it to the 72.
What did you add to 34 to get to 46?
6.
Okay.
And the same on the other side. 70 plus 6 was 76.
Okay. So you kind of knew that if you shifted it on a number line, that it would be the same problem, but this one was easier. All right. Did you follow what Grant did?
Yes.
All right. Are we convinced this is 36?
Yes.
All right.
Okay, all right, I'd like you to turn and talk to someone around you about some of your observations from this clip, and then we'll pull back together again. What were some of your noticings? Questions it raised for you, observations you had? Okay, if you could, again, begin to wrap up that conversation. Kind of finish that last thought and pull back again. Okay. Lots of things to talk about here, but one of the ideas I want us to be thinking about is kind of an overarching principle of a number talk, is that you have to have a safe learning environment. Right? And I think we saw beautiful evidence of that in this particular classroom, where even though it's toward the beginning of the school year, about the 5th or 6th weekend, the teacher has already been able to craft an environment of respect, where students feel safe enough to be able to put out answers that maybe they're not quite sure about, put out their thinking and saying, you know, I've now heard this other response and it's making me question mine and I don't think it's right, but I'm not sure why. Okay. That's what we want to have happen. It's that conversation. You have students that are interacting with others, sharing those ideas, exchanging ideas, which in turn makes us think about our own thinking. Right? So that, again, as a class community, we come back and have decided through our proof, our mathematical proof that's been offered, what is the correct answer. So that learning environment is critical, and the teacher sets the tone for that. She keeps that in place, and she keeps it honored throughout. Another important idea that I think we want to be thinking about if we're wanting the ideas to come from students without us telling, is that you choose purposeful problems. And let me give you just a few examples of that. For instance, if I want the idea of using a friendly number or a landmark number to come up from students, then if I choose problems that end in 9s, I can almost guarantee you that at least one of my students will bring that idea forward. And when they bring it forward versus me just telling, let me show you a way, then it's got a little more power to it, because it puts it out there for other students to begin thinking about. And we can say, all right, Sue has brought up an interesting idea. Do you think it would always work? Let's try it on a different problem. So the purposefulness is important. If I want students to begin thinking about using doubles, plus and minus something, or looking for that, then if I choose a problem that has some friendly doubles in it or really close to each other with that, then I can almost guarantee that somebody's going to bring that idea forward. The same notion with compensation, taking from one number and giving from another. If I make that one number we want to give something to just one away from a friendly 10, then again, there's a high probability of it coming from the students. So that's an important idea, community and purposefulness of problems.